Good afternoon, everyone. So, as he said, I'm the co-founder and principal engineer, or one of them, at Fastly. Before Fastly, I was one of the early operations engineers at Wikia. And before that, I did a little bit of everything, including SCO and Solaris and all kinds of fun stuff. So, I work for Fastly. We are a content delivery network. We handle a lot of the stuff that you've probably seen on the internet. I almost guarantee you've hit our servers every single day of your life. We handle currently, I think, around almost 900,000 HTTP requests a second on a daily basis. So rather active site. So a little history about that. Our first racks at Fastly, we focused in the early days on very efficient machines, so we could handle quite a lot of user traffic. Our average machine these days, depending on the workload, handles up to about 30 gigabits of traffic each. So we didn't have to add a lot of machines when we were in those early days of the growth curve. So we didn't do it very often. So each POP we built around the world was only around 2 to 6 machines. So it was kind of hard to justify doing much of a automatic boot infrastructure for something you do once or twice a month, and is pretty straightforward. And everywhere we had just remote IPMI. So that's its own little kind of hell, but it works. Because we had so few machines, though, we really didn't have. When you have 2 machines, it's hard to justify putting in a third one to be able to run a net boot infrastructure off of. So we just didn't do it. We also had a bit of organic growth. So we would install one of these locations, and then we'd add another one. And when we go to add another one, we discover, oh, crap, we didn't ship cables with this one. So we have to deal with that, and all these little things. And then it's somebody adding to an existing infrastructure. I don't know how many of you use remote hands for dealing with hardware. Being a CDN, we have locations all over the world. Only 2 of our data centers are actually near our people. So we deal with remote hands people a lot. Every time you engage them, there's risk. If they're going into an active cage, they may knock a cable, they may do something wrong, they may unplug the wrong thing, they may plug in a loop and create a nice storm on your network. All kinds of little things can go bad. So having a growth profile where we kept adding these machines was kind of ridiculous. And the business also started growing. So we were not only adding more facilities, we were needing larger and larger, more and more capacity in each individual facility. So I pulled this off our website today. So this is our current network location map. I don't know, it's like 18, 19, something like that. Quite a lot of locations. So each one of these represents 1 or more racks of equipment, and up to about 16 nodes in each one of those racks. So a fair bit of hardware. So part of that was what we call our mega design. So we've been through quite a few iterations of what a POP looks like in the Fastly design. The supers, we really want to forget. We're almost free of them. So the megas are our latest. And we look at these things as our smallest unit of deploy. So we don't incrementally grow these things. We just drop these chunks of equipment in places. So we also simplified the hardware build. We use the exact same equipment, we just vary the numbers of it. So the number of switches, the number of cache nodes that goes in each one of these is identical. So we can start making assumptions around the basic platform and the units involved. Plus, now we're shipping, say, 16 machines. Putting a tiny little 1U management server in there is kind of a lot easier to justify. And then you also have the fun of DDoS that makes that also nice. So having this consistency, we're able to lean on convention and not have to do as much by hand. So here's what a hardware rack looks like. So one thing you can take away from this is we ship an insane number of network connections per machine. Each machine has 9 network ports. We ship 6 of them populated. So this is what we would call a Mega 16, a fully populated rack, and then the Mega 4. The Mega 4 is the one I cabled. I did it pretty. Our network guys do a much better job, though. So this little machine, this 1U machine, we call our OOB machine. They're just a little tiny Haswell machine, nice little thing. But each one has their own private link to the internet. So everything is its own little island. So if we are under DDoS, we always have this little thing as our jump box available, but it also gives us a point for bringing everything else up. We configure this one point on the network, everything can be built off of that. So we use these to provide local provisioning. So the normal DHCP, Squid for doing the install, and Donner, which I'll get to in just a moment. So I looked at a lot of the existing tools for this. So you got Cobbler coming out of the Red Hat world, which is rather nice, does an amazing number of things, and is a massive volume of code, but kind of cool. Razor's a relatively recent thing. Originally came out of EMC, and is now was rewritten in Ruby by Puppet Labs, and I think Fletcher here gave a talk on it last year. It's actually really, really nice, and if it weren't for a few things, I would have chosen that one right away. Foreman is also another one in this vein that's kind of cool, and then I guess you could throw Crowbar in this area as well. So not existing ones. Well, we have like 20 plus locations. These locations are run as little islands. They don't have any other connection to the outside infrastructure. They don't depend on each other. They're isolated failure domains. So doing things like, say, have a central DHCP server with DHCP relay over a VPN, not going to fly. Having a master database that these tools connect over from a local instance over a database, not really going to fly. So that made it a little difficult on what we're going to do with these things. Most of them are also quite a number of moving pieces. So you do have various databases that they come with, and they're all their own source of truth for these things. Also, our networks are stupid complex. We do some interesting things, but it bleeds the complexity all the way down to the edge nodes. So representing what we wanted to in most of these systems was kind of painful. So I wrote this little thing called Donner. I'm sorry, it's not ready for open source release today. Heartbleed happened and kind of drained my will to live for a few days. So it's just a little tiny Sinatra app that takes stuff out of Chef and makes it available to a boot server. It is a boot server. It leverages iPXE and uses Chef as the entire source of truth for the system. No external data store, just Chef. So who here has heard of iPXE? Yay! It is one of the most brilliant things out there. It makes me very, very happy. So it's got a very long history, GPXE and Etherboot. I used it way back in the Etherboot project when I was burning into 3COM 3C509 NICs and doing Linux terminal servers. Those were fun. But it's stuck around because this PXE thing is actually a useful little blob of, it's a lever into these systems. And it's incredibly flexible in how you can use it. So on machines that you don't have ROM access, you can boot this thing off a USB stick, a hard drive, floppy disk. You can make PXE boot itself. That one's kind of cool too. And it's also incredibly more flexible. So normal PXE that's built into your network cards, it only uses TFTP to get the image sources. So you don't really have a TFTP API that you can write against that reads this thing, though I did come up with a really stupid hack the other morning for that. You could actually wire that up to a fused file system too. The way TFTP and PXE work as it iterates through the MAC addresses, you could just have one listening as a stat and return that data. I didn't write that, but it was kind of cool. So you can boot off more targets than just TFTP. So HTTP is the one I care most about, but you can give it all these nice little things. It's also very scriptable. It's a very ugly scripting language and really limited, but it's enough for some useful things. You can also do some hardware introspection. You can get at DMI data from within iPXE and write scripting around those DMI data results. Or you can return it back to whatever your boot server is. So for Chef, it's already something we have across our entire infrastructure. So it's something that has to be available. So I don't have to provision something locally. We've just assumed that these things over the internet will be able to access Chef. Having this data elsewhere, the number of times in production we've been bitten by having multiple sources of truth or locations for this data, various types of data, of operational data, has been painful. So I didn't want to have a separate database that needed to be backed up and maintained to go along with this. And data bags are kind of useful. Data bags are a thing that's easy to access from other tools. So even if it's just a Knife client, or I'm sorry, just using Knife to upload little blobs, it's not bad. And then you have things like Ridley that make accessing it pretty easy as well. So for data bags, I didn't want this to be part of the node object. So I could just say a node exists, it has these extra hardware properties, it should become this. But I've run into problems around some of that thing, some things like that, where are you creating a fully livable node object? So as a node object comes to the system, you have things that depend on it. I've gotten in trouble by things like node IP address not existing in the right places at the right time, or having an incomplete node object and having to write lots of guards around your queries. The things you expect an initial Chef client run, replicating that is kind of eh. It's also very easy to consume. It just is a nice, simple, opaque blob of JavaScript. There's really nothing else to it. It's just a put. And then the other thing I did with this is I used partial search, because I'm really lazy and don't like Ridley that much. So partial search is one of my favorite APIs of Chef in the last few years. I don't think we have any regular searches left. It's consistently fast, so instead of returning entire serialized node objects, it returns exactly the data you asked for. So it's actually fast enough to use inline in an HTTP request response cycle. I've taken partial search and hooked it up to Bootstrap and Sinatra and made quick little viewers into the Chef data. So just running search queries like, give me all the nodes in this data center of this property and put it on a web page. And it returns in like 200 milliseconds. It's kind of nice. The easiest hack with it is to grab the partial search cookbook. In the libraries, there's a partialsearch.rb. Drop that in your project file and do a require relative. And it pulls in Chef and makes partial search work. Really, really easy. So around this, we had to define the workflow of how things get in the data center. So when I wrote this tool, it wasn't just, I need to net boot stuff. It's like, how do my guys on the floor that install the hardware communicate with us, and how do we identify these things? Remember, we're working with remote hands people, and we're using Supermicro hardware. The serial numbers for Supermicro hardware is up under the lip in the PCI slot, which is kind of inconvenient. So if you're a remote hands person, having them fit through the rack to find a serial number is not an ideal situation. So we label all this stuff. So putting these labels on there means you're now binding a serial number to a physical location. So what we do is we get a manifest, we cable it, rack it, we map these things, and then we just start turning stuff on. So one thing that helps is we get vendor data. So a lot of the other tools you'll see out there have a nice collection step. I didn't have to do that. So we get a spreadsheet from our vendor every time we ship out a batch of machines with the serial numbers and the MAC addresses of that hardware. Most of them will give this to you if you ask for it. Some just do it by default. Then we just wrote a tiny little script that takes a PowerPoint or a Excel spreadsheet and does a little bit of ETL and turns it into a data bag that looks like this. So that's the entirety of a boot. I haven't quite gotten around to wrapping this in a knife plugin yet. I did that for one of my earlier systems. I made it look exactly like Cobbler. So you just put the command line just like that, and it worked. So a very little bit of data, mostly how to find the machine and how to boot it. So on site, we ship hardware. We have if it's of this type, this batch of hardware goes out and things arrive. We have all the normal elevations and cable diagrams and everything you need to get remote hands to do these things. The people on site, as they're racking these things, starting from the top, it gets marked number 20 and is number 35 at the bottom of the rack. It's not worth explaining why that number starts there. So then they look up and match these things. So they fill in that last piece of data. So we take the vendor spreadsheet plus the guys on site tagging these things, and now we have a point in space that we can say each machine with this thing is this, do this. So they add the serial mappings. I really want to get this to the point that there's actually a little barcode reader on their phones. So they just read the serial numbers off the computers and tag them with what they are. I haven't done the iPhone stuff yet. I need to do that. So once you actually have this data, we want to take a bare metal machine and make it run Chef. That's the end result. We just want enough to run Chef. So you get an address. You have to figure out what to boot. You have to give it, so once you've decided what to boot, say a Ubuntu installer, now you have to present the configuration, what you've passed into the pre-seed file or kickstart on Red Hat. then you tend to have a post install because that can't actually, that won't give you a result that's actually useful all the way. Then you run it through install, reboot, and chef, and then you're done. So first step in that is, how do you get iPXE so you can get over HTTP? So one of the cool things about iPXE is it comes with this driver called UNDI only, which is something you can serve over TFTP and PXE to a node, have it to restart and rerun DHCP again as iPXE. So ISE DHCP server has this handy little thing that you can essentially treat this as a user agent. So a node comes up, if it's not coming from iPXE, send it down this boot file and restart an iPXE. If it is, then we tell it a URL to go do, and that's the chain load. And this next little bit is kind of cool. That matches an Arista switch. So if we detect that it's a DHCP request coming from a switch, we have an endpoint specifically for configuring those as well. So in iPXE, you see to get the UNDI only and you're booting. So one of the cool things about iPXE then is that you can script your boot. So what this does is we come in, we're giving a little tag. So if we're on net 0, which is so it enumerates all the network cards in the system as it detects them, so you can actually pick which one you want to try to boot off of. So it tries to run DHCP on net 0. If it gets a response, it goes to the target and chain loads its configuration based on its MAC address. Converts the MAC address here to a hyphenated form, just because I was lazy and that was the easiest API, and then goes and boots. So this first step, you ran iPXE, it's like, okay, now I'm going to chain load my config. So you have that HTTP access point, so you have that lever. So that says, now you can decide what programmatically to do. Do you want to boot into an installer? Do you want to boot into, say, a BIOS update disk or a mem test to debug these machines? So this state and this profile can be set externally. So, and then you get an installer. So this is an iPXE script. So this is what would get returned by that first step. So all we're doing now is we're just setting the kernel in initRD. And you can see a little bit of ERB gunk in there. And it's just saying, boot this kernel, this initRD. If you get them both back over HTTP, cool, go. Otherwise, drop into a debug shell and the admin can figure it out. Pretty straightforward. And then after that, now you've got an ERB template generated for your pre-seed files. You're here to go, and it's just pre-seed. It's a horrid language, but it works. All this really is. I don't know if you've ever worked with these systems before. I've written like 3 of them now. This is the first one was actually dynamic. The others were just spit templates out onto disk. This one was kind of fun. So post-install is where we have to do all the fun stuff, which is all very site-specific, other than here's how you get Chef on the box. Our network's installed. Has anybody ever heard of BIOS dev name? Okay, so this is something cool that's come in the last, came out of some work by Dell and Red Hat. So if you have multiple network adapters in a system, you can get into a race condition where it doesn't reliably detect them in the proper order. So this one may be, the PCI card may get ETH0 and ETH1 this boot, and the built-in may get something else. That does get persisted in UDEV, so it's only on the install. But if you're trying to install and say this port is connected to this switch with these settings, it's kind of painful. So what BIOS dev name does is gives all of those network cards stable names. So the manufacturers of the hardware mark the hardware as these are embedded interfaces. So it'll do EM0 and EM1 for the embedded ones. The PCI adapters get enabled by their port. So a dual port card in slot 3 will get P3 P1 and P3 P2, which is actually really handy. Fedora and CentOS 6 should do it out of the box. Ubuntu, you just give it a boot line config flag and it'll do it. It made my life so much easier. Like I said, we have 9 network adapters in these things. Having to configure all those by hand was painful. And then Chef, we're not using the install sh method of doing Chef. We have our own repos in there, but yeah, it's the easy part from there. So like I said, this is also for more than just installers. It's not currently stateful. It will just boot whatever profile you tell it. It doesn't have any more intelligence than that, but that can be useful. So a lot of hardware these days doesn't have very convenient update mechanisms from Linux. So you have to boot into DOS to manage these things. So being able to say, on your next boot, run this image, upgrade your BIOS, and then after that, boot back into normal is kind of useful. So there's a thing that's part of the syslinux project called memdisk. So you pass it a memdisk ISO as the kernel, and an initRD as the thing you actually want to boot, and this will boot that. So a FreeDOS image plus a little blob from Supermicro, and you have an automated BIOS updater. If you want to take it even further, you can yank the DMI data out via OHI and schedule an exact one to boot to process on your next boot. Kind of useful. But you can also use this same technique to boot, say, a live debug image. So I have a desktop image startup that has a set of tools so you can debug outside of the installed file systems. Or boot into memtest86 to have it run a hardware diagnostic. It's just this lever where you can pull into your infrastructure and change these things. And then with IPMI, you can do things like IPMI, MC, chassis, PXE, or next boot, boot dev PXE. So you can tell it on the next device, on the next boot, just hit it here. Or you can have your hardware put it there. There's another option that you can have it just boot the hard drive. So you can say the default profiles always boot off the hard drive. Oh, I forgot to put menu support in there too. Another thing you can do is also generate menus. So you can have a boot menu off the network that will show all the ISOs so you could boot any image you want. And it can do HTTPS and HTTP, so you can boot remote images that way too. Kind of nice. So network gear, I showed the little thing in the ISC configs. So Arista in particular, and Juniper is also starting to support this now, have this thing called ZTP. It's a zero-touch protocol. It's very much like PXE, except for network gear. So instead of having to do TFTP, it's already built as HTTP. So when the gear comes up, it makes a DHCP call, and in that it gets back a file name to request, which is the URL for the server. And then it sends a GET with the serial number and MAC address of the piece of gear in the headers. So this is a little bit of Sinatra that says, hey, I'm going to pull out the Arista MAC, and then I'm going to return a template based on the data from that. I was really sad that I didn't do it sooner. It took like 10 minutes to actually get working. And then from there, you can just auto-install based on a template model your entire network gear as well. There's some other talks, I'm not sure if there's any this time, about automating the after and doing your in-place mutation using Chef. We're not doing that yet. But that was the big thing. I do have one extension of this that I haven't gotten on there that we're working on now. So we're also starting to embed this into switches. So however many of you have worked with Arista before? Wow, you guys are going to love this. So Aristas run Linux inside of them. They have a dual core. In the gear we have some dual core and AMD processors. Some of them have up to 16 gigs of memory in them. They run Linux. They have an official extension mechanism. They also run KVM and libvirt. So you can take a QCal image, upload it, and then assign a VM that has access to whatever set of VLANs management and internal that you want, and boot this little thing. So we have an omnibus package for our boot system that goes into a Debian image that's put into a QCal and is booted by a switch. And we're to the point that we're trying to be able to provision an entire data center by just shipping a single switch and plugging it into the internet.
Assuming all your machines are already plugged into the switch.
Yes. But one of the problems we had was we also do what we call private POPs. So where we sell managed devices like appliances to customers. This is some of our larger customers do this, and we manage them on site for them. We have to pre-configure them to match their local network gear because in a lot of cases we have no local network other than through the machines. So it's kind of been interesting. So we're flipping the model so that we drop ship the hardware directly and ship this switch, and everything gets plugged into that, and we can auto-configure from there. It's kind of fun stuff. So do we have any questions?
Doesn't sound. Oh, there. Now it's on. So you were talking about running basically cookout inside in the Arista. Do you run like kind of your management software in there then? Would you run DHCP and?
Yes, this would run DHCP, and just this would be so the Arista does have a DHCP relay. They have their own compiled version of DNS mask, but it compiles out DHCP server support, so it's kind of useless. So this is a way to get it in there and support it via this image. So you can run it in the outer container as well. It's just pain. Mostly it's pain of porting things to Fedora Core 14.
And where do you run your Chef server?
Chef server lives out on the internet, is passed through a Squid proxy running on the management machine. Once the machines are up and have their own internet access, they can get out there. It's run as a service.
Oh, so you're running hosted Chef?
Yes, a mix
okay,
of, yeah.
That makes sense. All right, okay. All right, thanks.
Yeah. Okay. Yes.
When do you expect this to be released, Donner?
In the next few days. I'll announce it on Twitter, and I don't know where else I can link from there, but I had a goal at the Chef Summit this year to stop releasing code in GISTs and actually put something out on GitHub. So this is the follow-through with that effort, is getting this available. The actual body of code is shockingly small. If you ignore the template data, it's about 100 lines of code.
Are you doing the PXE to iPXE bootstrap still, or since you have a whole bunch of NICs, are you actually flashing iPXE?
I haven't gotten enough trust with the flashing of the Intel NICs to be comfortable with, so I'm still doing the UNDI. I did discover today that there is a way to blend the PXE Linux boot, the traditional way we would do it, sending that image back, with iPXE. It's not built by default, but there's a way to build a combined version. So you can just return the PXE Linux.0 files you would in a normal one, and that would have iPXE built in.
Cool.
Are you integrating any of this work with Chef Metal?
I'm happy to talk with them about it. Chef Metal doesn't solve the problems I have. I've looked over some of the stuff. I've looked over the code for Razor extensively. Razor is very good. There's a lot of good stuff in there, and if you're running in a single data center and can run Razor as a service within that data center, it's awesome. It's gotten much better since the old Node.js version. It's really clean code and makes good use of iPXE. The infrastructure bits around. Oh, sorry.
You mentioned that there were a couple of things in Razor that prevented you from just adopting that and using it. What were those?
The biggest one was running the infrastructure to support Razor itself. There was nothing we had, and since we don't have a VPN or an internal network between these things, running the support services for it over the internet were not terribly pleasant. So this was an afternoon hack. Most of the time spent waiting on hardware to boot. I don't know if you've ever tried to develop one of these things, but it's ridiculously hard to get into a flow when it takes 10 minutes for every iteration.
I've actually built something very similar to this. It's kind of strange how similar it is. But have you used anything to start wiping disks besides something like dban? Have you developed or came across any other projects?
So one of the things we build into our images is HDParm, and we do secure erase on our SSDs. Provided the controller doesn't get in the way, that works pretty well. In VM cases, we've used shred before, something reasonable. This is designed not to preserve anything. It just blindly wipes everything that was there existing. In our use case, that's fine. But that stuff is really whatever you put in your pre-seed file and how you configure that. I really wish that the Debian and Ubuntu Kickstart support was actually complete. It would be very much nicer than dealing with pre-seed. Or if somebody wants to write a chef-driven installer, I'd be down for that too.
Doing it right now.
Woohoo! Okay. Okay, I have one little bonus thing. There's a cookbook I tried to release today and failed. Has anyone ever heard of ACPI ERST? Awesome. So this is this thing called the Emergency Record Serialized Emergency Serialized Record Table, something like that. So what this is a little block of 8 kilobytes of NVRAM on your motherboard. This is useful for so the Linux kernel now. Windows has used this for a while. Linux now has a driver for this. So if you have this mounted when your machine crashes, it will persist dmessage to it. So now you have kernel crash dumps for free. And they will persist across reboots, and they will survive even if it's your disk controller or network controller for remote syslog that is broken. So I have a little cookbook that automates this, because really all it is mount a file system and an init script to copy them out. So it's, I've discovered most people don't troll lwn.net's kernel page and figure these things out. So I'm trying to tell people about this one. Okay. I will be around for the rest of the conference. I'm wearing a bright red shirt the whole time, so come find me if you want to talk.